Hello and welcome to Meter Data Analysis with Onesait Metering. Before I introduce today's presenters, I want to make sure everyone's familiar with the conference platform. On the right side of your screen, you'll find a chat area. You're welcome to have an open dialogue with other attendees in that area. Each chat area is specific to each session. There is also a main chat area on the home page if you want to make general event comments. Just below this main presentation area, you'll find any relevant downloads for this session. Should you have a question for today's presenters, we recommend you send them a direct message using the community menu on the left side. Your speakers today are Giovanni Polizzi and Francisco Arroyo. Giovanni is the VP of Sales and Marketing for Minsait ACS. Francisco is the Manager and Intelligence Solution Owner for Minsait. Giovanni, if you're ready, I will turn it over to you.
Thank you, Delena. So let me kick this off by saying that, okay, we have, of course, data in utility. We're going to show how utility are using this data today, or utilities can use the data today. Data is, of course, used to see how events have happened in the past, but also to forecast decision on future occurrences. Today, we're going to see mainly the metering data, how metering data is leveraged to extract valuable information. We're going to see how a utility can implement this data across different business areas. We're going to talk about customer. We're going to talk about performance of the network, so more technical versus more customer-oriented information. And then we're going to show a quick win, how a utility can start with a small data set and then scale up to a fully deployed data analytics solution. The four use cases we're going to see today with Fran are, one is the load analysis. We're going to start from customer level and then going all the way up to system level, comparing benchmark recent demand with historic data. We're going to locate and identify service transformers, so the low voltage transformers, and we're going to find their load exceptions and detect performance deviation. We're also going to analyze and determine demand patterns, very much related with trends and patterns in customers' behavior in terms of demand, which is a very useful use case to determine which are the best time of use rates. And then we're going to see the forecast algorithm that we already implemented in the application. And now we can forecast it 24 hours ahead, or up to, for example, a week ahead of the information, which is a very valuable set of information for operation, of course. Fran is going to explain to us the different dashboards. In this particular case, we have the analysis domain dashboard. So this is all relative to load analysis. So I'm going to pass the word on to Fran about this particular analysis domain.
This case is called load analysis. The aim of this use case is to analyze system load. Also, any other magnitude existing in the system could be analyzed. To do that, we have different gadgets available that run depending on the user selection, period and magnitude to be analyzed, and also the asset or group of assets selection, supply points, feeder, substation, or any other asset aggregation available in the navigation map gadget or in the asset tree. So consumption is the first thing, demand. We can analyze the trends of how the demand is being increasing based on long-term historical data, either for a particular supply point, feeder, or substation, or even for other asset aggregation available. This allows us to understand how the demand trend is being evolved along the time. Data quality is also important. So that shows us the percentage of actual registered data versus estimated data. This is always important, as stated before. Peak or off-peak energy KPIs to understand how the customers are being using the energy during different times in the day. Consumption blocks or distribution of load to understand how demand is built along a particular period. For instance, for a particular month, you can analyze the difference among the daily consumption blocks. Example, analyze how the type of the day affected the consumption block, or identify any abnormal consumption in a particular period, okay? Also, we have a trend about demand versus temperature, okay? So comparing demand versus temperature, which is important as temperature is the magnitude that affects the consumption in a relevant way. And finally, we have the last trend, which is our stack plot variables. How variables influences on the load time series, temperature and other weather magnitudes like humidity, dew point, precipitation, pressure, wind direction, wind speed, and also the day of the week or time of the day, okay? So all these relevant magnitudes are included in a machine learning supervised model called random forestry that applies here, providing a very interesting and handy result, as you can see.
Thank you, Fran. So now we're going to see the next dashboard. So this is the data we saw before was relative to the analysis of metering. In this case, we aggregate information at transformer level, and we're trying to detect which are the anomalies in terms of operation. So peak loads or very low load. For example, a transformer that's been for a number of intervals been showing a steep increase or a steep decrease of demand, or just a very high demand on a longer period. And again, Fran is going to explain us this particular dashboard.
So the next use case is the service transformer load analysis. The aim of this use case is to analyze how the demand is affecting the service transformers. So to do that, we need first to aggregate the data at service transformer level, of course. So first, we can analyze the transformer overload. I mean, how many transformers are hit, for instance, the 100% of the rating in a particular period of time. So depending on the granularity of the data, for instance, hourly data, we can analyze how many hourly intervals that particular transformer is under or more 100% of its rating. These are examples. Or for instance, how many intervals the transformer is operating between 0%, 20% of the rating, etc. So there are several out-of-the-box analytical models providing different rating analysis, and users are able to define new ones in an easy and flexible way. For instance, the overloading analysis, I mean more than 100% of the rating. Another one, upper 86 periods. That means that more than 6 continued intervals between 80% and 100% of the rating. We have also less than 5% of the rating, or even a sliding window model with the capability of being trained with historical data. Thus provide a sliding window of limits that allow to analyze more precisely when there is an anomaly in the transformer load based on historical patterns. So we have also some KPIs providing immediately information to operators, for instance, number of anomalies of the period for the period, anomaly grade, and so on. So review historical load is also very important to analyze for a particular period of time in the past and for a particular transformer or substation how many times low predefined threshold has been exceeded, I mean overloading. We can also do that analysis at substation levels. For instance, in a particular neighborhood where are a lot of DERs, distributed energy resources, I mean distributed generation, it's interesting to analyze that the load for that particular neighborhood is different for another neighborhood where DER are not present. And another important variable is to understand which are the most frequently hours where the transformer is overloaded.
Thank you. So quite an interesting point of view, as Fran was showing, to understand how the network is behaving from basically how it has changed from the initial design. For example, the case of showing one neighborhood against versus another neighborhood. It's also a very important case to compare neighborhoods that have different penetration of solar panels, for example, or storage or electric vehicles. So it becomes a very useful information for planning and for operations in the network. The next dashboard that we're going to see is the clustering analysis. In this case, we are comparing different behaviors of clusters of customers. And again, Frank is going to explain to us how this dashboard is working.
The next use case is clustering analysis. The objective of this use case is mainly to provide insights about customer consumption patterns. I mean, grouping into different clusters all the customer supply points we have in the system and considering the 24 hours load and some statistics as maximum, minimum, and average load. So getting all this information, we can see at a very high level what are the patterns of our customer, avoiding go one by one looking at each of the patterns, okay? So as usual, the application allows us to exploit this information through different gadgets. I'm talking about KPI, trends, maps, graphs, and tables. So in the graphs, we are able to look into the different centers of or the pattern characterization for a particular cluster. We also be able to get the density for every cluster as well as the average consumption level, the deviation, and so on. And we also can compare the cluster itself with each of the metering points. So all the intelligence behind this is a machine learning and supervised learning algorithm called K-means. So a part of understanding the behavior of our customers, there are other applications deriving for the customer analysis that are maybe useful to undertake. One of them is tariff recommendations. So based on clusterization analysis, we can recommend our customer chain of tariff. It is possible to undertake tariff simulation and analyze the monetization associated of this tariff simulation, assuming that our customers are going to change their consumption patterns. And also another potential use case is the fraud detection. So in case we detect a transformer with non-technical losses, we can analyze the meters that are hanging from this transformer and look at those meters if they have changed in consumption behavior in the last year and so on.
So very important point of view, of course, is try to understand how customers are consuming their energy and promoting the time of use rate, for example, to display as part of the peak demand in clusters associated with promotional particular rates at a particular time, or if we see, for example, in the neighborhood there is a peak of demand associated with electric vehicles, then a special rate for electric vehicles, for example, late at night could be an incentive. And the tool gives immediate quantitative information to make that decision. And also, as Fran was saying, the possibility to simulate what the new rate would look like in terms of consumption, considering that the customers have changed their behavior. Now we're going to see the last dashboard. So this is the forecast analysis. In this case, we are forecasting demand, again, from customer level up to the system level. We can forecast with a number of variables, as we will see, a number of external variables, as for example, weather information, wind, humidity, temperature. We can aggregate at a substation level to give that information, for example, the 24 hours ahead to operation, to control center. We can do it over the entire week. Of course, depends on the quality of data of the forecasting station and the definition, granularity of that data with respect to the covered area of the network. So I'll pass the word again to Fran to go through this explanation.
Next use case is forecasting analysis. The forecasting analysis can be applied in our application to different time series magnitudes and can be done for 24 hours ahead up to 1 week ahead. So in this case, I'm presenting the particular use case for load forecast based in weather forecast. So in order to undertake this forecasting analysis, we analyze the influencing factor that try to explain the consumption, and we analyze also the different meteorological magnitudes such as temperature, humidity, dew points, precipitation, pressure, wind direction, wind speed, together with the type of the day and some seasonable variables. So the user can understand better what are the drivers that influence this consumption forecast. Also, we set up the library pack with a set of methodologies to undertake the forecast, and user is allowed to define the parameters that he wishes to use for each of the methods. So again here, data quality is a key variable to be considered because the result of the forecast model will be only acceptable if a minimum percentage of the data quality level is exceeded. And in this case, the analytic model is based on artificial intelligence, deep learning. And this specific one is a long short-term memory model. As well as the forecasting use case itself, we also include some forecast deviation analysis to better understand what is the robustness of our models. So to do that, we calculate some KPIs such as mean absolute percentage error or weighted mean absolute percentage error. We also undertake this metric on the peak and off-peak intervals, and we also plot our errors, if there is any, to understand in terms of the day, of the week, or the consumption level, and so on. I had to say that it becomes very important to use correctly the forecast. So one of the questions we will normally be asked is, can you forecast 1 week ahead? Of course we can. And the more ahead we go, the more precise the data we need for weather for information. Regarding how granular can the weather information be to give a more precise forecast analysis of demand, I have to say that it's very important which data can be stored or which data can be retrieved from the weather forecast website or providers. One of the most important things is to get metering data associated to particular GPS coordinates, and from that, we can link to a particular weather forecast station and that region to retrieve valuable data to fit our forecasting algorithm.
So very important, the last observation. Of course, the good quality forecast, weather forecast data is a key element in the quality of the forecast that we can get in terms of expected demand. Now, if we think about demand at substation level, then that's a very important information for the operation, for whoever is running the control center to understand if some switching plan is to be put in place to avoid the peak at a particular substation contingencies at a particular circuit. This becomes particularly important now that the demand is changing very fast and significantly because of the presence of electric vehicles. And as we know, normally electric vehicles start to grow more in some of the neighborhoods, not across the entire network. So some of the neighborhoods will, for them, the forecast of demand becomes particularly important. We're going to see today, after this, is a quick start. So it's a proposal basically to start a data analytics with metering information. We would normally recommend to start, for example, with a proof of value or with a pilot project where we test the models. We test the model, we prioritize use cases. That's a consulting work that we do with clients. We start with small data sets to try to understand also the quality of data, especially when we talk about metering data, there are gaps. So there can be gaps or data can be associated wrongly to transformers, for example. The session meter transformer can be incomplete. So starting with a small data set gives us the immediate idea of the quality of data. Normally between 1 month and 4 months, this is what a proof of value will normally come into place. And after the 4th month, we analyze what the results are. Basically, we analyze which new information is available, how easy it is to obtain this new information, which are the stakeholders involved. Sometimes we start with a small group of people within the company, and then we see that the interest of data goes across different departments, so we have to bring in more stakeholders for a larger deployment. We identify who use the data, so to ask for correctly for their requirements. And then we also see the availability and correctness and richness of all the required data. So we start with metering, but then we need, for example, asset information from the GIS. We need customer information from the customer information system. We may also need building information to analyze how much energy is being billed versus how much energy is being measured. Once we decide and we give a financial value to the analytics that we can deploy, then we can start the ramp up project. And for ramp up, we mean a progressive incremental deployment. we try to use out-of-the-box functionality. So everything that you've already seen in this presentation, those out-of-the-box functionality are ideal because they're already available. They can be configured, parameterized, and they don't require new developers. So we kind of in promoting the fast deployment rather than a very precise requirements of the company. Then we gradually increase the size of data sets. We structure the data pipelines for automatic inputs. For example, in the proof of value, we would use a manual upload of information, 1 year, 2 year of data. Whereas when we do the ramp up, we start to create the data pipelines for automatic input. And then we start to increase the number of analytical models. So we start with the out of the box functionality, and then we go into the, we start to increase the number of analytics models that are available in the system and that the company organization may require. Finally, after month 12, we start to the consolidation process. The consolidation basically means consolidate with complete data sets. So we don't do any more with partial data sets with reduced amount of information. We develop new use cases from the analytic models. We structure a service to maintain and improve models. The last dashboard that we've seen, of course, measure the errors of the forecasting algorithm, for example. So we can start to analyze if there is a constant deviation from across the increment of errors, so that the models that we have developed that would need some maintenance. We monetize the investment. So the utility can actually start to monetize the investment done, because it's when the new efficient processes can be put in place. More information will for example, more information to operation will generate more efficient operation. And then slowly the transformation of business process can be implemented. So we're talking more about change management approach by using the learnings from the analytics. I hope this entire presentation has been interesting to all of you that have been listening. For those of you who have little information on Minsait ACS, I just wanted to introduce briefly Minsait ACS. Some of you, of course, are customers, so you know, but just a reminder, Minsait ACS is part of Indra, a much larger international corporation. And Indra is doing an effort with all their clients to transform business and society, because of the size, of course, through innovative people-centric solutions and services. In particular, Indra's got different business, but in the energy business, we do work with more than 200 utilities in USA. We have many multinational energy corporations that we work with in the world, and we have our solution delivers services to more than 200 million final customers across the world. So we're pretty proud, and we can say we have a lot of expertise in this field, and we help a lot of companies to change their business, to improve their business, and most of all, to improve the service they provide to their customers. Indra and Minsait have an entire suite of products specifically for the utilities, from customer information system to metering, as we've seen, intelligence, for generation, and for markets. So please feel free to contact us for any other information that you may require on our solution. And with this, I want to close the presentation and pass the word back to Delena to do the final closing. Thank you.
Awesome. Thank you, Giovanni. Thank you, Fran. Appreciate your time today. I also want to thank everyone for joining today's session. Be sure to look through the sessions menu to add any sessions you might have missed while registering. Also, please take a moment to check out our event sponsors in the exhibitor area. These sponsors are the reason we're able to bring you this interactive virtual conference this year at no additional cost. So definitely go over there and show them some love. Thanks again, and we'll see you on the next session. Have a good day, everybody.